Hello everyone. In this lesson, I will discuss radian and degree measure in trigonometry. Specific objectives of this lesson are describing angles, using radian measure, using degree measure, and then using angles to model and solve real-world problems. First thing we're going to do is we're going to go ahead and describe what an angle is. In the Greek language, the word trigonometry means measurement of triangles. Initially, trigonometry dealt with relationships among the sides and angles of triangles because those are the components of triangles. And in trigonometry, people were interested in looking at sides, doing some measurements, and investigating angles. We define an angle as determined by rotating any ray or half line about its endpoint. The starting point of the ray is the initial side. As you can see in purple, we have this initial side, which is going to be our initial ray. And then what we're going to do is we're going to rotate this ray, and then we're going to get this other side, which we call terminal side, which is basically the end point or where the ray stays. And then this difference is going to be what we call an angle. So to be able to have an angle, we have to have a terminal side and the initial side and terminal side. The endpoint of the ray is the vertex of the angle. This perception of an angle fits a coordinate system in which the origin is the vertex and the initial side coincides with the positive x-axis. As you can see, this origin becomes the vertex of the angle now. Vertex of the angle. The angle itself is right here, and then we still have the initial side, we have the terminal side, and using this perception is what we call using the angles in a standard position. And we're pretty familiar with this coordinate system because we've seen it before. It's a two-dimensional coordinate system where you have x and y, two variables represented on a coordinate plane. Counterclockwise rotation generates positive angles. So if you go from right to left, in other words, you're going to end up having positive angles. If you choose to do the other side, then you're going to end up having negative angles. If you go clockwise, you'll have negative angles. In mathematics, we generally label angles using alpha, beta, and theta, letters like these. And in the figure 4.4, we note that alpha and beta have the same initial and terminal sides. You guys realize on the first image we have alpha to looks like this, so initial side, end side, or terminal side. And then for beta, we use the same initial side and we end up using the same terminal side. It's just different perspective. And you guys realize alpha and beta are coterminal. Whenever angles share the same initial and terminal sides, we call them coterminal angles. Coterminal. And you may have different variations of this. If you end up just going from here to here, you just have alpha. But then if you just like continue doing the same kind of movement, so you start with the initial side, you just keep going and having like a one full rotation and then ending up at the same place will create this beta angle. And you guys realize alpha and beta are still coterminals. All right, next thing we're gonna do is we're gonna talk about radian measure. So people in a lot of mathematicians and other people have been thinking about how to measure angles. So one way to measure angle is using this idea of radians. So we're going to describe how it works, but to define a radian, we're going to use a central angle of a circle, and then the vertex is going to be 0, 0, or the center of the circle. And then what we're going to do is we're going to have some angle that is going to have initial side, which is r, so the length of this initial side is r, and then we have the terminal side, which is still the same thing, same length, and then it's gonna look like that. So you guys realize the initial side and terminal side have the same length, which is the radius of the circle, r. So one way we can define what this angle theta is, one way we can measure this is what we can do is we could take a look at that arc length that it creates. Do you guys see this blue arc length right here? So this blue arc length is what we say S. So S is that arc length, and what we're gonna do is we're gonna divide that arc length by the radius r, which is the length of radius. So radius r. So this is, folks, what we call radian measure. So this is what we call radian measure. So this is one way we can measure the length of angles. Here we have formal definition, as you can see. Because the circumference of a circle is 2 pi r, it follows that if we have one full revolution, we're going to end up having the arc length being 2 pi r. You may be wondering, how does that happen? So let me show you how that actually happens. So I'm going to draw a circle. I'm going to have some angle. So like say this is my r, this is my vertex. You guys realize I have my initial side. So what I'm going to do is I'm going to have one full rotation. I'm intentionally not copying the same thing so you guys can see initial. So I did one full rotation like this. So this is my angle. So let's call this angle to be theta. So if I do one full rotation, then the length of this, or the measure of this theta, is gonna be S over R. You guys realize S is the arc length, so circumference of the arc length in general is, you guys realize S, the arc length, is 2 pi r, because this whole thing is 2 pi r. This whole thing is, the length of this whole thing is 2 pi r. So we're gonna do 2 pi r, because that would be the corresponding arc length, because I did one full rotation. And then I'm going to divide that by r, which is the length of my radius. So you guys realize r's will cancel, so then my theta just becomes 2 pi. So what that means is that one full revolution, counterclockwise of course, will produce 2 pi radian measure. So 2 pi radian measure is why, the reason why one full rotation is 2 pi radians is because of this reason, where circumference being 2 pi r. So because we know one full rotation, one full revolution, I would say, revolution is 2 pi, and because we know 2 pi in general, because 2 pi is, pi is approximately 3.14, because of that reason, 2 pi is around 6.28. And what that would imply is that we can only create around 6 radius lengths in a full circle. So you guys realize 1 radian, 2 radian, 3 radians, 4 radians, 5 radians, and 6 radians. We cannot create more than 6 radian measures, because we know that 2 pi is approximately 6.28 radians. For that reason, we can only have 6 radians at most. All right, because the measure of an angle of one full rotation is S over R, arc length divided by radius, which is equal to 2 pi, like we just talked about, we can obtain the following information. So instead of having, so we know that one revolution, one rev, is 2 pi. If we decide to do half of a revolution, then we'll divide 2 pi by 2, and then we'll get pi. If we decide to have 1/4 of a revolution, then we'll divide 2 pi by 4, and then we'll get pi over 2 radians. If we decide to do 1/6 of a revolution, then we'll divide by 6 and we'll get pi over 3 radians. So these are just some random numbers that we divided one full revolution. If you decide to divide, if you decide to have 1/8 of a revolution, with the similar reasoning, you can just divide 2 pi by 8 and then get pi over 4 radians. So as you guys can see, depending on how your revolution look like, you can find the corresponding measure for the angle. If you want to do just 1/8 of one full revolution, then you can have pi over 4 radians. So here are a couple of diagrams for what we're just talking about. So again, if instead of having one full revolution, if we want to have 1/6 of a revolution, so 1/6 of a full revolution, you're gonna have something like angle looking like pi or theta looking like 2 pi over 6 because we have 1/6 of a revolution. This is actually 1/12 of a revolution. The represented image actually represents 1/12 of a revolution. So that's why we do 2 pi over 12 and we end up getting pi over 6. So pi over 6 radians is actually an angle measure corresponding to 1/12 of a full revolution. So this last image is one full rev. So this one is 1/2 of a rev. This guy 1/4 of a rev. Like I was describing earlier, the way we got pi over 2 is because we divided 2 pi by 4 and that equivalence is pi over 2. So you can do the same, apply the same idea for this one and that one and all the ones that I didn't talk so far. All right, now we move on to this idea of quadrants, and coordinate system has 4 pieces. Like you may remember before, we have quadrant 1, quadrant 2, quadrant 3, quadrant 4. So based on this idea of revolution, we can divide these into pieces where we have different measures, different radian measures for angles. So if my angle is from 0 degrees, 0 radians, and pi over 2 radians, then I'm always going to be at quadrant 1. But my angle is bigger than a pi, for instance, and smaller than 3.3 pi over 2, then I'm always going to end up at quadrant 3. So one example for that is, like, imagine I have some angle right here. I'm going to rotate this and then end up somewhere here. So you guys realize this angle right here that I just created, so let's call it alpha. So let's say alpha is like pi plus, so pi over 4, something like this. So you guys realize this angle is going to be like 5 pi over 4. So this is bigger than pi because I have pi plus pi over 4, and it's smaller than 3 pi over 2, which is this like whole thing right there represented. And so that alpha will have pi over 4 and it'll be in quadrant 3. Okay? So we're gonna work on more examples like this in the future. So we're gonna note that angles between 0 and pi over 2 are acute angles, and angles between pi over 2 and pi are obtuse angles. So this is something we should probably keep in mind. Okay, so I think here we go back to this idea of coterminal angles. We're going to say two angles are coterminal when they have the same initial and terminal sides, like we talked before. We're going to be able to find an angle that is coterminal to a given angle theta by adding or subtracting 2 pi. So we can always find a coterminal of a given angle by adding or subtracting 2 pi. And I'm going to demonstrate that in example 1 pretty soon. So here is an example. So you guys realize the angle that I'm given is something like pi over 6. So my alpha is pi over 6. What I want to find is I want to find a coterminal for this guy. So the way I can do that is I can just add pi to this angle, 2 pi to this angle, and then get a coterminal, and I'll call it theta. So that angle will look like something like when you add these two, do the math here. So this one's over 1, multiply by 6, so 12, so 13 pi over 6. So then realize alpha and theta are coterminal. And then you guys realize alpha is given in blue right here, and then the other one is in pink or red. I'm gonna draw you guys, and you guys realize this guy is my theta, which is 13 pi over 6. Another example of this is we're gonna use the same thing, but we're gonna subtract from 2 pi. So the way it's gonna work is that the given angle that I have is negative 2 pi over 3. So this is my theta. You guys realize I can create a coterminal for this by going the opposite direction. So instead of going negative direction, kind of like what this theta guy did, instead of going this direction, I'm going to go to the other direction. So I'm going to go this direction all the way, and I'm going to create this other angle that I call it alpha. So the way I can find alpha is by subtracting 2 pi from that given angle, 2 pi over 3. So I can compute what that is, and I think that's equal to something like 4 pi over 3, right? So you guys realize theta and alpha are coterminal angles, and we found that by subtracting that angle from 2 pi. So next we're going to talk about this idea of radian measures and some interesting things about radian measures. So if we have two positive angles, alpha and beta, so these angles are complementary if their sum is equal to pi over 2. And then whenever we move on to degree measures, we're going to learn that pi over 2 is going to be the same thing as 90 degrees, but I'm not there yet. So for now, we just know that complementary angles equal to pi over 2. So you guys realize on the first image, alpha plus beta has to give you pi over 2. Two positive angles are supplementary when their sum is pi radians. So on the second image, you guys realize alpha plus beta creates one full pi, which is what we call 180 degrees. And we're going to learn that pretty soon. All right, so now we talk about degree measure. A second way to measure angles is in degrees. And we denote this by this like little circle symbol. A measure of 1 degree, so represented as 1 degrees, is equivalent to a rotation of 1 over 360 of a complete revolution about the vertex. All right, so you may be wondering, what does that mean? What that means is that one full rotation is divided into 360 degrees. So imagine you're having like all these like small pieces. So all these small pieces, so 360 pieces. So what it does is it just divides that whole distance, one full revolution, into 360 pieces. And when you take one piece is going to be equivalent to 1 over 360. And that's what it is. To measure angles, it is convenient to mark degrees on the circumference of a circle as shown on this image. So you guys realize this theta specifically given in the example is going from here to there. It ends up right here in this terminal angle. You guys realize this seems to be 1/8 of 360. So 1/8 of a full revolution, full rev. And that's why we have 360 over 8, which seems to be equal to 45 degrees. So this takes 45 degrees, this angle theta. Okay, so then we're going to have, because one full revolution is 360, then a half revolution must be 180. A quarter revolution then must be 90 degrees. So if we have something like this, then going from X to Y, this is 90 degrees. From going here to here, now with the total is, let me use a different color for the total. So now going from here to there is 180. And if I want to continue going more, I'm going to end up at this side, which is 270 degrees. And then if I decide to complete one full revolution, I'm going to have this green angle that is going to be equal to 360 degree measures. All right, now we describe all this. And then now we're going to relate degrees versus radians, right? Radians is a different way of measuring angles. Degrees is different way of measuring angles. So to relate these guys, so one full rev for degrees, you may remember. So one full rev, one rev. In degrees is 360, in radians is 2 pi. So what that means is then 360 degree must be the same thing as 2 pi. So that's how we know these two measures are the same. Because one full revolution for degrees is 360, one full revolution for radians is 2 pi. So in total, they're going to be 360 equals 2 pi. Or one half rotation instead of one full rotation, we're going to have 180 degrees, same thing as pi. So this is how we know how we relate these two guys. In mathematics, we're generally interested in converting between degrees and radians because that is something cool to do. So to convert degrees to radians, we multiply the degrees by pi over 180. To convert radians to degrees, we multiply radians by 180 over pi. Okay, so here are some equivalent degrees. We have 30 degrees equal to pi over 6, 45 degrees equal to pi over 4. All that you can compute for yourself. Okay, so generally in mathematics, if we don't provide units of angle measure, then it probably means it's in radians. So if we don't write it, then it's generally radian. So like pi theta equals 2 implies that theta equals 2 radians. Okay, keep that in mind. So here I'm going to provide an example for converting from degrees to radians. So if we're given 135, you guys realize this is in degrees. What I want to do is I'm going to convert this degree angle into radians. So the way I'm going to do that is I'm going to multiply my angle by pi over 180. And then the way I do that is just simple math. Simplify these, and then you'll get 135 over 180 pi. And then just simplify this. I think you divide by 45, and then you get 3 over 5. 3 over 4, I mean. 3 over 4. So 3 pi over 4. Let's convert 540. Similarly, multiply that by pi over 180. Degrees will simplify, so divide 540 over 180, and then that should give you something like 3, because 180 times 3 is 540. So 3 pi radians. In general, I always recommend converting into simplest, so please try to simplify as much as you can. Simplify as much as you can. And I'm going to take a break for the application for now.